All right, let's dive right in. Today, we're going to be cosmic detectives, traveling way, way back in time to solve a pretty big puzzle. We're on the hunt for a lost chapter in the universe's history, a time when, and you might not believe this, the entire cosmos was actually hitting the brakes.
You've probably heard this question a million times. It's one of the biggest mysteries out there. We look up and everything is flying apart from everything else, faster and faster every second. But what if I told you this whole acceleration thing is actually pretty new?
That's the kicker, isn't it? For the vast, vast majority of cosmic history, the complete opposite was happening. So this is the story of how our universe flipped the script, going from slowing down to speeding up.
To really get how we got here, we have to start our journey in a much earlier age. This was a time when gravity was the undisputed king of the cosmos. There was this epic tug-of-war going on, and for a long time, gravity was winning.
And this right here is the period we're diving into, the matter-dominated era. For billions of years, the combined gravity of all the stuff in the universe, stars, galaxies, all that dark matter, was so powerful that it acted like a giant cosmic brake fighting against the expansion that started with the Big Bang.
So how in the world did matter become the boss of the entire universe? Well, to figure that out, we have to rewind to the very beginning, when matter had some pretty serious competition.
In the super early universe, it was basically a showdown between matter and radiation, or light. As the universe got bigger, both of them got less dense. But here's the crucial part. Look at the difference in how their densities decreased. Matter's density dropped, sure, but radiation's energy density dropped even faster. Why? Because as space itself was stretching, the light waves were also being stretched out. We call this redshift. That little difference meant that matter was always destined to win in the long run.
And you know what? That win came pretty quickly, cosmically speaking. Just about 47,000 years after the Big Bang. A blink of an eye, really. Matter's density officially became greater than radiation's. From that moment on, gravity was in charge, and the expansion of the universe started to slow down.
But matter's reign as the cosmic champ, well, it wasn't going to last forever. There was a new, super mysterious force just kind of waiting in the shadows, getting ready to cause another huge change in the story of the universe. So this is where a brand new tug-of-war started. On one side, you've got matter. Its positive pressure is basically the pull of gravity we all know and love. It's the cosmic brakes. But on the other side, you've got this thing we call dark energy. It has negative pressure, which is just a fancy way of saying it's an anti-gravity force. It's the cosmic accelerator, pushing everything apart.
And this timeline just lays it all out perfectly. For more than 9 billion years, matter's brakes were winning the fight. But the universe just kept on expanding, and the matter within it got more and more spread out. Eventually, around 9.8 billion years in, matter became so diluted that the constant, relentless push from dark energy finally took over. And that's when our current age of accelerated expansion kicked off. And that's really the heart of the standard model of cosmology. The simple fact is that the universe spent most of its life slowing down, just because the gravitational pull from all the stuff inside it was the strongest game in town.
Okay, so that's the standard story. It's pretty clean, it makes a lot of sense. But what if the very evidence we're basing all this on is actually pointing to something completely different?
Now this is a pretty radical question, I know, but it's the core of a whole other theory. Redshift, the fact that light from far-off galaxies gets stretched to redder colors, is our #1 piece of evidence for an expanding universe. But what if? What if it's caused by something else entirely? So this alternative model just throws out the rulebook. It proposes that the universe isn't expanding at all. Instead, it suggests that everything we interpret as expansion and acceleration is just a kind of cosmic optical illusion. Okay, so if space isn't stretching, then where does redshift come from? Well, this model has a couple of ideas. First, imagine time isn't a constant. What if space-time itself is slightly deformed, causing time to tick just a little bit slower over huge distances? That would make things look stretched out or redshifted. Another idea is called transit redshift. You can think of it as tired light. As photons travel for billions of years, maybe they bump into stray particles and lose just a tiny bit of energy, shifting their color toward red. Either one of those could make it look like the universe is expanding.
So where does that leave us? We've got two completely different pictures of our universe, and both of them are trying to explain the exact same things we see through our telescopes.
Let's just put them side by side. The standard model,
It says redshift is happening because the fabric of space is literally expanding, and the acceleration is a real physical thing caused by dark energy. The alternative model, it says, nope, redshift is because time is slowing down and light is getting tired. And that acceleration we see, that's just an optical trick, an illusion created by how this redshift effect gets bigger with distance.
So really, when you boil it all down, it comes to this fundamental question. Is the universe physically getting bigger, being pushed apart by some mysterious energy? Or are we just being fooled by the very nature of time and the long, long journey light has to take to get to us?
One story gives us a dynamic, accelerating cosmos that exploded from a Big Bang. The other suggests a static universe where our very perception of time and light creates this grand illusion of motion. The evidence we see is the same for both. The interpretation is everything. And that is a fascinating puzzle to chew on.